Hi, today I'll be talking about atomic bonding. For this topic, the first thing we need to know would be atomic structure. For this, we will learn about the protons, neutrons, and electrons. Secondly, we will need to learn about the electronic configuration of an atom. And lastly, we will need to learn about ionization energy. In this video, I'll be talking about atomic structure. Before we begin, first things first. What is an atom? An atom is basically the smallest component of an element. An atom consists of three main units, which is the electron, the neutron, and the proton. These are the three subatomic particles that are present in an atom. Next, we are also required to know about the relative charges and relative masses of these atoms. Do note that these values are relative and not absolute. They are relative because they have no units, and these are essentially the ratios between these particles. Relatively, the electron has a charge of -1, the proton has a charge of +1, and the neutron has a charge of 0. In terms of relative masses, the electron is 1/1836 the mass of a neutron and a proton, which can both be considered to have the same mass of 1. This tells us that the electron is extremely light when compared to the proton or the neutron. Next, I'll be going through how these three subatomic particles behave in an electric field. Now, let me draw an electric field. On one side, it will be positively charged, and this is called the anode. And on the other side, it will be negatively charged, and this is called the cathode. All three particles will behave differently in the electric field as they have different masses and charges as we have explained above. When the neutron enters the electric field, it will remain undeflected given that it is neutral. Hence, it will travel through the electric field in a straight line. For the proton, it will be deflected to the cathode since it is positively charged. For the electron, it will be deflected to the other side, to the anode, since the electron is negatively charged. It is important to note that the angle of deflection of the electron will be greater than the proton. This is because the angle of deflection of the particles is proportional to their charge divided by their mass. Both the electron and the proton has the same charge value of 1. So, if we look at their mass instead, we will realize that the electron is much lighter as compared to the proton. This will give it a much larger angle of deflection. This is an important formula that we will need to know for our A levels. To use this formula, we write it down as angle of deflection equals to K multiplied by charge over mass. In this case, K will be a constant. Next, I'll be talking about the mass and charge distribution in an atom. Here is a schematic representation of an atom. In the middle of the atom lies the nucleus, where we can find the protons and the neutrons. The nucleus is surrounded by electrons, which forms the electron cloud. The nucleus contributes almost all of the mass of an atom because of the relatively large masses of both the neutron and the proton as compared to the electron. Proportionally, the nucleus contributes to over 99.99% of the total mass of the atom. The nucleus will also be positively charged, given that it comprises of only the protons, which are positively charged, and the neutrons, which are neutral. Next, I will be explaining what proton and nucleon numbers are. If we look at the periodic table, we will always see a number above and below each element. The top number is the proton number, while the bottom number is the nucleon number. So, what do these numbers represent? The proton number represents the number of protons in the nucleus. The nucleon number, which is also known as the mass number, is the sum of the total number of protons and neutrons in the nucleus of the atom. With this information, if we want to know the number of neutrons, we simply take the mass number and subtract the proton number from it. Now, let us use carbon as an example. Since carbon has a proton number of 6, the carbon atom has 6 protons. To find the number of neutrons, we simply take 12 minus 6, where we subtract the proton number from the nucleon number. Next, how do we find the number of electrons? To do this, we need to understand that an atom is electronically neutral, which means that it will have a charge of 0. Hence, a carbon atom will have 6 electrons, as we will need 6 electrons to balance the charge of the 6 protons for it to be neutral. The last concept that I will be going through today would be isotopes. So, what are isotopes? An isotope is defined as the atoms of an element with the same number of protons and electrons, but they will have a different number of neutrons. As isotopes have the same number of protons, they will have the same proton number. As they have a different number of neutrons, they will have different nucleon numbers. An example of an element with isotopes would be oxygen, where it can exist as both either oxygen-16 or oxygen-18. As you can see, both isotopes will have the same number of protons. In this case, oxygen-16 and oxygen-18 both have 8 protons. However, for the neutrons, oxygen-16 has 8 neutrons, while oxygen-18 will have 10 neutrons, given that they have different nucleon numbers. We calculate the number of neutrons by subtracting the number of protons from the nucleon number. Now, the last thing that I will go through today would be about the properties of isotopes. This is something that is also commonly tested in the exams. There are 2 different properties that we need to know. Firstly, we need to know that isotopes have similar chemical properties. This is because they have the same number of valence electrons. Secondly, we also need to know that isotopes have different physical properties, given that they have different relative isotopic masses, which is due to their different nucleon numbers. Now, I've reached the end of this video. If you find this video helpful, I will be grateful if you can give a like and a subscribe. In the next video, I'll be introducing more about various types of electronic configurations.